Welcome to solverfy.
We have to calculate the range of the projectile, which has a length of 57 meters, and it's railgun. Yeah, sorry, not the projectile, the railgun. And this railgun is located at 41 degree above the horizontal. So let's sketch this system. So that is a horizontal line. So the railgun is here. It is 57-meter long, and it fires a projectile, and the projectile obeys the parabolic trajectory. It reaches the ground somewhere here, and we basically so let's presume that here we have to calculate this length, the overall length, from which includes actually no, let's say that we will be calculating this length from the top of from the end of the projectile. So we have to calculate this range. The projectile, sorry, the railgun is located at angle alpha, and the the projectile which leaves the railgun has a velocity of v0. First, we have to calculate this velocity of v0. V0 equals to the distance, the length of the projectile equals to v0 squared divided by 2a, because the projectile is being accelerated here. Therefore, v0 equals to 2a, to square root of 2al, which is square root of 57.0 times 2 times 7.2, and it's all in meters per second. Let's calculate this number. It equals to 28.6 meters per second. Okay, we've calculated the initial velocity. When the projectile leaves this railgun, it will be directed. It will be located at some height above the ground. So let's introduce the x, the y, and x-axis, and the initial coordinates of the projectile after it leaves the railgun, y0 and x0. And y0, obviously, like from this triangle, y0 equals to L times sine alpha, x0 equals to L times cosine alpha. So y0 is 57.0 times sine of 41 degree, and x0 equals to 57.0 times cosine 41 degree. Let's calculate these two numbers. So the first one is 37.4 meters, and the second coordinate is 43 meters, 43.0 meters. Okay, that's good. So now let's move on to the next step, and let's calculate v0x and v0y, the initial projections of the projectile on the x and y axis. v0x equals to V0 times cosine alpha, and V0y equals to V0 times sine alpha. And Vx as a function of time is constant, and it's always V0 for sine alpha because there is no horizontal force, there is only vertical force, which is gravity. And Vy as a function of time equals to that equals to V0y minus gt, which is V0 sine alpha minus gt. So now let's calculate the moment of time when this velocity is zero. So when y0 is zero, then maximum height of flight is achieved. And therefore let's presume that it's achieved at time equals to t1. So then v0 sine alpha minus gt equals to t1 equals to 0, then t1 equals to v0 sine alpha over g. So v0 we've already calculated this. It is 28.6 meters per second times sine of 41 degree over g. Let's calculate it. It equals to 1.91 seconds. Actually 1.92 seconds. So this is the time after which the projectile will have only horizontal component of its velocity. So total time of flight equals to t1 plus t2, where t2 is the time which is needed to go from h max down to y equals to 0. So basically here this is h max, then the time of this motion is t2. During this time of t2, horizontal coordinate changes from h maximum to 0. Therefore, t2 equal or h maximum equals to gt2 squared over 2 because initial y velocity is 0 in this case. So then t2 equals to square root of 2h maximum over g. Now we have to calculate h maximum. Y coordinate of the projectile equals to y0 plus v0 sine alpha t minus gt squared over 2. So then h maximum equals to y as a moment of t1, which is y0 plus v0 sine alpha t1 minus gt1 squared over 2. Then maximum velocity equals to y0. Y0 is here, it's 37.4 meters plus v0, which is 28.6 meters per second, times sine of 41 degree times 1.92 seconds minus 9.80 over 2 times 1.92 seconds squared. Let's calculate this number. It equals to 55.4 meters. Yeah, let's double check it. Yeah, it seems to be correct. And now let's calculate T2. So T2 equals to square root of 2H maximum divided by G. Oh, sorry. Oh, that's no. It equals to 3.36 seconds. So that's the time of landing. Then total time of the flight equals to T1, which is 192 seconds plus 3.36 seconds. We can calculate this number now. It equals to 5.28 seconds. Oops. Then the total time of the total range equals to V0, basically horizontal velocity times time of the flight. So it's V0 times cosine alpha times time of the flight, or 28.6 meters per second times cosine of 41 degree times 5.28 seconds. Let's calculate it. It equals to 114 meters. So that's the solution of this problem. I hope I helped you. Thank you very much for your attention. Bye.